Okay, we're going to look at a different way of looking at probability problems, and they're with discrete random variables. So DRV is discrete random variable, and we'll look at probability distributions of the discrete random variable. So what's a random variable? It's a variable that has random numbers as its value. And we have discrete or continuous. So discrete random variables, the values that the variable takes are usually whole numbers, 0, 1, 2, 3, 4, whole numbers. And then continuous random variable would be when the values that the variable can have are all real numbers in an interval. So we have all the decimals and fractions. Discrete or continuous. So would we talk about the weight of a fish that you may catch? Would that be using discrete or continuous numbers? So we're measuring the fish. We can have all kinds of fractions of a weight, so that would be continuous. A continuous random variable would represent the weight of the fish that you may catch. When you roll a die, the number that shows on a die, that would be discrete because you have 1 through 6 or however many faces there are on a die. The number of days that it will rain next month, so we would just count the number of days as whole numbers, and so that would be discrete. But the amount of rain that comes down next month would be, you could have all kinds of fractions there. We'd say that'd be a continuous random variable. Okay, so let's compare this to what we've seen already with probability. We've seen probability questions that might ask about outcomes of flipping a coin. If we wanted to represent this as a discrete random variable, we'd say x is the number of heads. And so we have to have this thing that we're counting, a variable, and it represents something that we're counting. We can, on a die, we can roll an odd number. Here we can say x is the number of odds that we roll. What's the probability of rolling a 1? Or we can say that x is the number showing. And if we roll 2 dice, what's the probability of rolling 2 4s? Well, now we can say x is the sum of the dice, and we could represent that as a random variable. Represent the probability distribution as a table and graph of the discrete random variable x, which is the number of tails in tossing a coin 3 times. Find the probability that x is greater than or equal to 2. So let's look at a tree. We can see what the sample space is for flipping a coin 3 times. So we can have heads or tails, and we flip it again. If we flipped heads the first time, then we can flip heads or tails. and then we can flip heads or tails. That would be the third flip. So we can see that that's heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. We can make a table of the probability distribution, and we're going to have, this is a lowercase x, and then here we have the probability that uppercase x equals lowercase x. X is the number of tails, so now we're going to look at what are the possible number of tails. Here we have 0 tails, so x could be 0, or we have 1 tail, or 2 tails, or 3 tails. Down here we have 3 tails, so 0 to 3 are the values of the random variable, and then we want to look at the probability of 0 tails. Well, that's the only way we can get it, so that we can say that's 1 out of 8, because we have 8 possibilities, and that's 1 out of those 8. 1 tail. There's 1, 2. We have 3, 1, 2, 3 ways of getting 1 tail. And then 2 tails. 1, 2, 3. We have 3 ways of getting 2 tails. 1 way of getting 3 tails. So here's the probability distribution, and also the one way you can check, and also there's questions, usually always one question asking or using the fact that these add up to 1. If you add all these up, it has to equal 1, and we can draw a graph. And then we just plot these points. Since it's discrete, we will only put the points. At 0, the probability is 1/8. At 1, it's 3/8. At 2, 3/8. And at 3, we have 1/8. Okay, and it asks the question, what's the probability that x is greater than or equal to 2? Probability that x is greater than or equal to 2 is going to be, it can be equal to 2, so we take that probability. Oops. 3/8. And then, or it could be 3, and that's 1/8. So we get 4/8. We can find the probability that way. Find the probability that x is less than 4 if x is the sum of 2 4-sided dice. Okay, and so here, 2 4-sided dice, we could make a tree, but with 2 dice, maybe a lattice would be better. So let's do this together, and then you can do the rest. So with first die, we can have 1, 2, 3, or 4. And then the second die, we're going to have 1, 2, 3, or 4. And we're looking for the sum of the two dice. So in a lattice, we can represent the sums in here. 1 plus 1, and we get a 2, 3, 4, 5. 2 plus 1, 3, 4, 5, 6. 6 is 4 plus 2. And we have 1 and 3, 4, 5, 6, 7, 4 and 1, 5, 6, 7, 8. And that lets us look at the sample space. These are all the possible outcomes. Okay, let's look at lowercase x. You want to write out the values that x can have if x is the sum of the two dice, and then the probability of capital X equaling that lowercase x. Okay, so you finish it, make the table, draw the graph, and find the probability. Pause the video. So the values of x, the sums of x. The sums go from 2 to 8. And the probability of a 2, we have 16 outcomes, and that's going to be 1 out of the 16. And then there are 2 3s, 3, and the 5s, we have 4 5s, we have 3 6s, 2 7s, and 1 8. And we can draw the graph. And the probabilities go up to 4/16. So 2 would go up to 1/16. 3, 4, 5 goes up to 4/16. And then we can come back down, and that would be the graph of the probability distribution. Let's look at the probability that x is less than 4. So we want values less than 4. That's a 2 or a 3, so we can just add these. So that equals 1 over 16 plus 2 over 16, 3 over 16. The probability distribution of capital X is the probability that capital X equals lowercase x is k over x for lowercase x is from 1 to 4. We should probably write this as a set since it's discrete, and the interval we would have to know that we're dealing with just natural numbers in there. So we can write it as a set. Find k and find the probability that x is between 2 and 4. So we have a formula for the probabilities, and we can fill out the distribution table, the probability that capital X equals lowercase x. The values of x are given 1, 2, 3, 4. And then we just have to calculate their probabilities, which is k over x. So if x is 1, we have k over 1. If x is 2, k over 2, k over 3, k over 4. And now we use that characteristic that all of these probabilities have to add up to 1. So we know that k over 1 plus k over 2 plus k over 3 plus k over 4 is 1. Then if we get a common denominator of 12, that'll be a 12k plus 6k plus 4k plus 3k over 12 equals 1. And we get 25k equals 12, so k is 12 over 25. Then, if we want to know the probability that 2 is less than or equal to x is less than or equal to 4, we're looking for outcomes of 2, 3, or 4, and so we just have to write down the sum of these probabilities. So 12 over 25 over 2, 12 over 25 times a half, and then 12 over 25 times a third, 12 over 25 times 1/4, and we get 13 over 25. The probability distribution of x is kx squared. All right, pause the video and try that one. The values of x, 0, 1, 2, 3. The probability of each of those is kx squared. So k times 0 squared, k times 1 squared, k times 2 squared, k times 3 squared, and we know that all of these have to add up to 1, so we have 9, 10, we have 14k equals 1, so k is 1 over 14. And then the probability that x is less than or equal to 2, we want the probability that it's 0, 1, or 2. Well, 0 probability there, we need k plus 4k. So that's going to be k is 1 over 14 plus 4 times 1 over 14. So this is k, that's the probability of getting a 1, and then 4 times k is the probability of getting a 2. So we get 4 plus 1, 5 over 14. Five white cubes and 4 red cubes are in an urn. An urn is just a container. 2 are selected without replacement. So that's important to notice. Without replacement means the sample space changes every time you remove one cube. If it is with replacement, then the probabilities are always the same every time. Represent the distribution of x, which is the number of white cubes find probability that we have less than 2 white cubes. Five white, 4 red. So now we have an urn. We have 5 white, 4 red. We could select a white or select a red. If we select a white, there would be 4 white and 4 red. If we select a red, there'll be 5 white and 3 red. That's the first selection, and 2 are selected. So now we have this. We could select a white or a red, white or a red. Now let's keep track of the probabilities. The probability of this selection is 5 out of 9, and here we have 4 out of 9. The probability of this is going to be 4 out of 8, and here is 4 out of 8. This is 5 out of 8 and 3 out of 8. Okay, we want x to be the number of white cubes. So here we would have 2 white cubes, 1 white cube, 1 white cube, 0 white cubes. And we can make the table. X has values 0, 1, or 2. The probability of each is going to be the product of these probabilities. So 0 white cubes is down here. That's 4 over 9 times 3 over 8. So it's going to be 12 over 72. 1 white cube is going to be either this path or that path. And here we have 20 over 72 and 20 over 72. So that's going to be 40 over 72. And then with 2 white cubes, it's going to be 20 over 72. So we're just, to get to this one, we're going white, white, 5 over 9 times 4 over 8, 20 over 72. There were 2 ways to get 1 white cube, so we had to add this plus that, and that's how we got the 40. We can check by adding these, and that equals 72 over 72. The probability that x is less than 2, that means it's going to be 0 or 1, so we just add these together. And we can reduce it to 13 over 18. Try one more. 7 red cubes and 5 green cubes are in a bag. 2 are selected without replacement. Represent the distribution of x. The number of red cubes. Find the probability x is greater than 0. All right, pause the video and try that one. Let's make a tree, and we have 7 red, 5 green. We could draw a red or a green. The probability of the red is 7 over 12, and the green is 5 over 12. Then, if it was with replacement, if it said with replacement, then we would still have 7 and 5, and the probabilities would be the same. This is without replacement, so we took it out and didn't put it back. That means now we have 6 red, 5 green. And down here we took out a green, so we have 4 green, 7 red. And we make the second selection. It could be red or green. And the probability of red is 6 out of 11. Green is 5 out of 11. Red, 7 out of 11. Green is 4 out of 11. And then we count the number of reds. So here we have 2 reds. Here we have 1 red, 1 red, and 0 reds. And we make the table. The probability, x can be 0, 1, or 2. the probability of 0 reds is down here with 2 greens, and we'll go 5 times 4 and 12 times 11. 20 over 132. And we can have one red 2 different ways. So here we have a 35 and 35, so that'll be 70 over 132. 35 plus 35. 2 reds. That's going to be 6 times 7, 42 over 132. And then we find the probability that x is greater than 0. Well, that means we could have 1, x could be 1 or 2, and we just add those together, and we get 112 over 132, and that reduces. We'll just leave it like that. And that's the end.